Hello, Professor. My name is Li Zexuan. I'd like to present my research title, Research on Correct User Chain Warning Model based on Ensemble Learning and Behavior Dynamic Characteristics. This study aims to address the challenges of customer attrition in the fact area through data-driven modeling. Let me first outline the presentation structure. We will start with the abstract, then move on to the problem statement, research objectives, methods, experimental results, and conclude with a discussion of our findings and eliminations. This follow will help us systematically explore the solution framework we've developed. Starting with the abstract, against the backdrop of fintech, third-party payment users have surged by 32%, drawing by customer acquisition costs up by 45%. To tackle class imbalance, only 6% churners and low traditional model accuracy, we built logistic regression, random forest, and stacking models. The stacking model start out with an AUC of 0.98 and 95% recall, highlighting transaction frequency 0.181 and amount 0.176 at key products. Now focusing on the problem statement. The industry faces two players, growing customer loss and raising acquisition costs. Data-wise, we encountered those class imbalance feature, redundancy, transaction count and amount correlated at 0.7, and traditional models with a recall rate below 60%. These issues necessitate a more robust predictive approach. My research objectives were threefold. First, to balance class distribution via smooth. Second, to construct a stacking model integrating logistic regression and random forest. Third, to develop a three-tier risk stratification framework for target interventions. Each objective aims to address the challenges and identified in the problem statement. Moving to methods, the data pipeline involved missing value imputation, smooth balancing, and feature selection. A tuned random forest identified to the top 15 features with behavioral traits like transaction frequency and amount for outperforming demographic factors. This shows behavioral dynamics are crucial for churn prediction. Regarding the model framework, we employed a stacking architecture where logistic regressions and random forest solved baseliners, capturing linear and non-linear patterns. A multi-liner then integrates their output, creating an ensemble of experts to mitigate individual model biases. This design leverages logistic regressions interpretably for linear trees and random forest robustness against noise in complete patterns. By combining these strengths, the starting model reduces variance and enhances correlation ability compared to single algorithm approaches. As the observer can better handle the non-line relationships inherent in customer behavioral data. Now to the results, the stacking model outperformed others with an AUC of 0.998, 94% recall, and 0.96 FE score compared to logistic regression and random forest. It shows a 7.3% LC improvement. This translated to a 98% higher recall than industry standards, means the model can identify 95 out of every 100 potential tuners. Such precision minimizes false negatives, potential save-back emailing in returns caused by targeting intuitions early for context. Each percentage point increase in recall could save an average back approximately $15,000 annually in lost revenue. Based on the model, we developed a risk stratification framework. High-risk users need dedicated managers and cashback. Middle-risk users receive personalized promotion, while low-risk users require basic maintenance. The high-risk tuner intervention combines dedicated managers to address relationship issues with cashbacks to incentives continued users. For example, weekly cashback offers equivalent to 5% of transaction amount have been shown to resolve transaction delay in 60% of cases with their most. Those monetization stressors potential efficiency. In discussion, behavioral features contributed over 35% of predictive power, while demographic account for less than 5%. This confirms that transaction dynamics like frequency and amount outline stake traits such as age or gender. The finding aligns with recent fintech studies showing customer behavior phase procedures by 1 to 3 quarters, making real-time behavioral tracking crucial. The model's 95% recall rates able backs to interval in nearly twice as many cases as the industry model, directly improving customer lifetime value matters for a typical campaign. This could extend the average retention by 2.5 months per user. Concluding, the stacking model proved example Linux effectiveness with transactions domestic drawing predictions. The 3-tenor risk filter offers actionable strangers for high, middle, and low risk segments, directly informing retention baggage. Limitations remain. First, the absence of time series analysis sees more behavior patterns like quarter transactions surges are uncaptured. Second, residual feature redundancies could be further reduced. Further work should integrate ARM-based time series model and apply PCAR for dimension reduction, aiming to balance accuracy with captionary efficiency for real-time development. Thank you for your attention.